Assalamualaikum and very good morning to everyone. Welcome to the class of Forensic Chemistry. On the 4th week, I'm Dr. Amy Shazwani Abdul Kinyon. Will be taking over the class given by Dr. Najib for the past 2 weeks. I'm going to cover several topics in Forensic Chemistry. The first one is sample preparation. Sample preparation is chapter number 2. To be specific, it's chapter 2A because there's another part 2B will be covered by Dr. Naji for the topic of amino acid. After that, after finish sample preparation, after preparation, we will go into the next topic, chapter number 3, which is the dye and ink and what is the chemistry behind it. And then we will move forward towards the polymer in forensic chemistry. Okay, so we will learn about polymer and so on, and then you will be directed to Dr. Naji again for blood alcohol concentration and also statistic. Okay, so let me find the pen first. I am the senior lecturer in analytical chemistry. Okay, I'm not forensic scientist per se, but I'm quite an expert in analytical chemistry. Therefore, any chemical analysis problems, also method development, I will help you to understand that. So, the question is, why analytical chemistry is important in forensic science, forensic chemistry per se? Because chemical analysis is the major experimental done to understand what is the evidence, how much is it inside that evidence, and so on. Okay, we will talk about that later in the next few slides, but before that, I can be reached other than the WhatsApp. And also my handphone number, you can email me at amy@utm.my for any further question. Okay. So at the end of this topic, you will learn about what is chemical analysis. Whether it's qualitative, or quantitative. Which one is needed most in forensic science? And then you will learn about the 9 steps in chemical analysis. Which involve the sample preparation that I will cover today. And then you will be given a real sample from real cases. So that you can see how relevant chemical analysis in general and sample preparation in specific in this analysis in real cases. And then number 5, you will be given the techniques, classification, how to classify chemical analysis. So back to my slide. Sample preparation is a step in quantitative chemical analysis. Before that, what is quantitative? From the keyword itself, we can predict that this is like an aspect in chemical analysis to know how much of the compound, chemical that we want. Because everything in this world is comprised of chemical compounds, even the water, even the air. So we want to quantify for any purpose. So quantitative chemical analysis consists of 1, 2, 3, 4, 5, 6, 7, 8. 8. Sometimes it is extended into 9 because sampling is stand on its own, okay, as compared to preservation and storage. But in this case, it's 8, but most of the time it's 9, okay. Okay, so where does the sample preparation stand in? So it's this one, okay. That's why, in the first place, I want to introduce what is quantitative chemical analysis first, rather than we jump into sample preparation, which is in the middle. Without understanding all this, is very difficult for us to understand, okay, especially if you are not from chemistry background. Okay, we will go one by one of each of these after I show you this next slide on the type of analysis. Okay, we have two. Quantitative analysis is an analysis to determine how much of analyte present in the sample. Like this one, this analogy of this cartoon said I can give 9.5 over 10 for her look, 9.10 for her choice of press, and 10 over 10 for her dressing sense. As long as numerical value is involved, that's what we call as quantitative. It doesn't matter if it's 10%, it doesn't matter if it's 10 part per million in chemical analysis, as long as numbers are there. While qualitative analysis is performed to identify what analytes present in the sample. Okay, so this cartoon only says, oh, she looks beautiful, her dress is awesome, and she dressed very well. So no numerical data, no numerical results. Therefore, this is what we call as qualitative. The question is, how this is relevant in forensic chemistry? Okay, go back to the main question. Do you want to know how much of cocaine inside a urine sample? Or do you want to know what is the drug, what is the type of drug in that urine sample? Okay, sometimes you want only to know what type of drug, whether it's like 1 part per million or is it 100 part per million, it doesn't matter. As long as the cocaine is there, you are guilty. Okay, so that's how important it is to identify what you want first. Okay. However, it is preferable in chemical analysis to go towards quantitative analysis because it's acceptable worldwide. Okay, Malaysian law in terms of homicide cases or civil cases, more of it is civil cases. We want quantitative analysis. We want quantity because it's valid, accurate for reporting. So, I will explain now what is analytical chemistry and how it plays a role. So, you must understand analytical chemistry is a very big branch, analytical chemistry. Okay. Chemical analysis is the subset inside analytical chemistry. Okay. And then another subset inside chemical analysis is our sample prep. Okay, in order for us to understand, let me change this one first. In order for us to understand the sample preparation, we have to understand the analytical chemistry. Okay, so analytical chemistry, it deals with the identification and determination of analytes in a sample. Analyte, what is analyte, what is sample, I will explain to you later. Basically, we want to know what's inside, okay? Is it benzene, is it paracetamol, or even is it parathion that kills people? It's a part of pesticide, okay? And then, how this separation is inside our statement. So this separation involves when you want a clean sample, and then this is where sample preparation comes in. Sample preparation use separation method. It separates from the clean sample out of the clean analyte out of the T sample. Okay. Analytical chemistry involves the application of range of technique. Okay, we will learn about technique a lot and methods. How many techniques and methodologies? Honestly speaking, millions of them. But it's my job for you to understand which one to use for a very specific sample. I will give you a classification on type of chemical analysis, and at the end of this subject you will know how to choose the correct technique and the correct method based on the chemical properties as well as physical and mechanical aspect that involved in it. Okay, so it involves the application of range of techniques to obtain and assess qualitative and quantitative, and sometimes you want to know structural information. Means if you want to know about nitrophenol, okay, you know already it's nitrophenol, you know how much is it, but do you know the chemical structure? Okay, analytical chemistry can plays a role on that as well. Okay. So this is, you can read this on your own. It is what I explained just now, yeah? Okay. What is analyte, matrix, and sample? Before I go into analyte and matrix, we understand first sample. Sample is the representative of the population or gross sample. Okay, means that if you have a lake as the whole water body, do you want to take the whole water as your sample? Of course no, because it's going to be irrelevant. Okay, therefore you take sample. Sample means that it is a representative of the whole lake. How many sample? So it's usually around 1/10 of the whole area. It's what we call as gross. And then when you have sample, for example, you have water sample. Okay, you want to, you suspect that the mercury content in the lake water is killing the fish. Okay, therefore, mercury is your analyte. Okay, mercury is your analyte. What is the meaning of analyte? Analyte is the matter or chemical compound that you want to identify, you want to detect using selected methods. Okay, therefore sample, water sample tadi, water sample contain mercury. Okay, do you think that the lake water only contain mercury? Kejap ya Mariam. Is containing all those rubbish as well. What is the rubbish? That's what we call as matrix. Matrix is the medium in which the analyte is analyzed. Okay, if let's say the water sample, lake water sample contains suspended solid, therefore suspended solid is your matrix. If it contains other metals such as nickel, so nickel is not your analyte, therefore nickel is your matrix. The question is matrix supposed to be inside that? Okay, it's not. It's in there in the first place because it's endogenous, but it's our job to get rid of all this suspended solid, nickel, whatever inside this. Why we want to get rid of them? Because it makes our life easier when we want to do chemical analysis using instrument. That's it. Okay, we want to eliminate all these constituents inside the sample except the analyte. We only want the mercury inside it. Everything else, just remove.